So our sun is a relatively typical star, sending energy in all directions. And the way it sends its energy is mostly via what we call radiation. And we talked about there's different wavelengths of electromagnetic radiation, different kind of, broadly speaking, members of a family of radiations. So when that radiation comes to the Earth, the first thing it's going to hit is the Earth's atmosphere. And depending upon which wavelength of energy you're talking about coming from the sun, it will interact differently with the Earth's atmosphere. For instance, that energy coming from the sun can be absorbed based upon, as you can see up here, it depends upon the particle in the Earth's atmosphere, the size of the particle and its nature that it's interacting with, and the wavelength that we're talking about. That energy can be transmitted through the Earth's atmosphere. Just basically, those particular particles don't care that that particular wavelength of energy from the sun is coming through. And also, the other thing in the Earth's atmosphere that can happen with the gases and aerosols is they can redirect energy from the sun. And again, it depends upon the particle that's doing the redirection, whether that's a nitrogen molecule or a carbon dioxide molecule or a particulate, a type of aerosol suspended in the Earth's atmosphere, and it depends upon the wavelength, because remember, the sun is sending us, gamma rays, X-rays, ultraviolet radiation, light, infrared, microwaves, and radio waves. And as I've listed them, that's basically from shortest to longest wavelength. So what's going to happen with that energy from the sun in the Earth's atmosphere? It depends, but these are our options. So up here at the top, and this is just kind of a typical day, you know, it will vary from day to day if what will happen to that incoming solar radiation. We call this insolation, the particular amount of energy that the Earth is privy to from our star, the sun. So if we kind of look at it 100% during the daytime, notice that actually 30% don't make it to the geosphere. It's redirected, and it's redirected by basically the stuff in the top part of the Earth's atmosphere. About 5% of that incoming radiation from the sun doesn't even penetrate the atmosphere. About 20%. Now again, the cloud cover will vary from day to day and from location to location, but the presence of clouds can have actually kind of a cooling effect on the geosphere if you're here at the Earth's surface. And here we see, depending upon the nature of your cloud, it can reflect 20%. Okay, the rest of the 30% of light that is scattered actually makes it to the geosphere, and the Earth scatters it back up. So collectively, can you see where 5% plus 20% plus 5% is the collective 30% that is reflected back into outer space? Well, what happens to the 70%? Well, again, I'm showing clouds here, but notice this 20% in general basically are clouds and the particles, aerosols and gas molecules in the Earth's atmosphere will absorb about 20% of that incoming solar radiation. Now, in something like gas particles or liquid water droplets in a cloud, when something absorbs energy like this 20%, what it does is it increases in temperature. Those particles move faster. So this would have a warming effect. So we're still lacking another 50% or so. 50% of, and this is just, you know, kind of ballparking, and notice that these will all add up to kind of equal, this is a balanced slide, but about 50% actually of the radiation coming from the sun will make it through the Earth's atmosphere, and it will make it to the geosphere, and that radiation will heat up the geosphere. So what happens then, you see the word absorbed down here. Actually, this is 50% of the radiation coming from the sun then is absorbed.